Okay, part 3, hyperbola. So by definition, a hyperbola is a set of all points x, y in a plane, the difference of whose distances from two distinct fixed points, which are the foci, is a positive constant. So again, the idea here is the following. So if we take the d1 and d2 and we subtract it. Now, I'm going to use absolute value symbols like this, because D1 could be bigger, D2 could be bigger, doesn't matter. But when you're doing distance, right, distance is always positive, so that's why we do the absolute value. This is also going to be equal to 2a. But now the shape of a hyperbola is different than an ellipse. So, a hyperbola is almost like you take the ellipse, break it in half, and split it out, right? Or take two parabolas and put them in opposite directions. So that's the idea here. So now your hyperbolas open up left and right, or up and down, depending on what the formula is, and what the transverse axis is. And now your foci are on the outside, right, where the hyperbolas open up too. So you do have a center, which is going to be the point equidistant from the two vertices, which are going to be where the hyperbolas like change direction, if you will. So the distance from the center to the vertex is that a. So your transverse axis, which goes between your two vertexes or vertices, that is going to be your length of 2a, right? The foci are still c units away from the center, so we can still use that idea. All right. So now, when you come down here, here's your two equations, depending on which way your hyperbola is open. So notice the minus sign in between your x and y. When your hyperbola is open horizontally, the x is the transverse axis is horizontally. That means the x comes first, and the y is negative. When the hyperbola is open up or down, that means your transverse axis is vertical. Your y is going to be positive in front. Your x is negative. Okay. And now to find your point C, or your length of C, how far the foci is away from the center, you're going to use this formula here: C equals a squared plus b squared. So the normal Pythagorean theorem. And again, as we did with ellipses, typically use that formula to find either your a or b value, depending on what you need. Typically your b value, because you're given your a value, because it's the main axis, in this case, the transverse axis. Okay, so again, I know it's a lot to handle. There's another part to this that involves what are called the slant asymptotes. I'm not quite ready to show you that. I just want to go over the formula and get a picture. Okay, but again, maybe you'll talk about asymptotes in algebra 2, and then maybe your pre-calc teacher will touch on this a little bit. All right, so let's do this problem together here. So it says example 5: given a hyperbola with vertices at 4, 1, and 4, 9, and foci at 4, 0, and 4, 10, find the standard form of the equation. All right, so let's go ahead and graph this real fast. So looks like it's positive. So I'm going to extend it farther this way. So 4, 1, 1, 2, 3, 4, 1. Put a red dot there. That's a vertex. And then 4, 9. So we'll keep going. This is 4, 9. Oh, let me redraw my graph. I didn't read this right. Sorry about that. So it's going to go vertical, right? So 4, like that. Okay. So 4, 1. 1, 2, 3, 4, 1, and then 4, 9, 2, 3, 4, 5, 6, 7, 8, 9, and then 4, 0, and 4, 10. Okay, so it looks like this x value of 4 is used a lot. So 4, 1, 4, 1, 4, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the vertices. So that's a vertex, that's a vertex. Foci are at 4, 0, and 4, 10. So what this means is your hyperbola is going to look something like this, right? It's going to open up like that, and it's going to open up like that. So this means that the transverse axis is vertical, which means the y comes first. So your formula is going to look like this, right? It's going to be the y minus k squared over a squared minus x minus h squared over b squared equals 1. Okay. So that's our formula. So we need h and k, which we have, our center, which we can find. We can find h and k. we need A, and we need B, which we can find as well. Okay, so first let's go on H and K. It's going to be midway in between your vertices. So again, I'm going to pinpoint it right here. So your center's at 4, and that's going to be 1, 2, 3, 4, 5, because 5 is equidistant between 1 and 9, right? 1 and 9, 5. So there's your H and K. Great. Now we need to find our A, which is our uh, uh, how we get our transverse axis, right? So again, A uh, is going to be the distance from your center to each vertex. So that would be a length of 4, right? From 5 to 1 is a length of 4. So I have my A. And now to find my B, I need to use the formula AC squared equals A squared plus B squared. Now I know my C as well. My C is the distance from the center to a foci. So this is a length of C. That's just going to be 5. So your value of C is 5. So 5 squared equals 4 squared plus B squared. 25 equals 16 plus B squared. Subtract 16. 9 equals B squared. Square root 3 is your B. And there we go. We have everything we need. So now we can go ahead and make our equation. I'm going to use orange. So here we go. So y minus k, so again, it's the y coordinate squared, over a, which is 4 squared, minus x minus h, which is the x coordinate of the center squared, over b squared, which is 3 squared equals 1. Square the denominators and you're done. So parenthesis y minus 5 squared over 16 minus parenthesis x minus 4 squared over 9, and that's going to equal 1. And there's your equation. And now we're going to go ahead and type both equations in. Oh, I'm sorry. Sorry, wrong problem. We're going to type in the vertices, the foci, and the hyperbola, and we're going to paste the graph below. So let's do that real fast. Graphing calculator. Okay, so 4, 1 was my first vertex. I'll call that V1. Doesn't matter. Oh, and let's zoom out one. All right, let's zoom out. Then they gave me 4, 9, which is my second vertex. We'll call that V2. Then they gave me 4, 0, which was the first focus. Call that F1. And then they gave me 4, 10, which was the second focus. Call F2. There we go. And now we're going to graph our hyperbola. Hopefully they go through the vertex and open up towards the foci. So my formula was parenthesis, or fraction parenthesis, y minus 5 squared, not 50, 5 squared, over 16, minus fraction, x minus 4 squared, over 9, equal 1. And there you go. Goes right through my vertex, opens up to the foci. Great. If you want to zoom out one more time, that's fine to get a better picture. I could care less. But again, copy and paste that graph on your problem. Remember, when you do task 5, almost done. When you do task 5, copy and paste it down here. And again, type out your work as you see fit. Okay, great. Task 5. One more task to go.